Precalculus Chapter 2.8, exercises 25 through 32. We're going to do the odd number problems in this set. In exercise 25 through 32, determine the real values of x that cause the function to be 0, undefined, positive, and negative. And for this, we're going to use number line analysis. And I'm going to introduce you to something, if you don't know already, called critical numbers. And critical numbers in a function here are going to be numbers, we'll say x values, where the function f of x is equal to 0, or I'll put f of x does not exist, or is undefined. But that'll be just a point of definition. But anyway, that'll be a general concept. Before that, we're going to set the numerator equal to 0. So if we put this x minus 1 is equal to 0, x equals 1 is one of our critical numbers. And likewise, we set our denominator equal to 0. We have quantity 2x plus 3 times quantity x minus 4 is equal to 0. And so using the zero factor property, 2x plus 3 is equal to 0, and also x minus 4 is equal to 0. And then we solve for x, so we have 2x is equal to negative 3, so x is equal to negative 3 over 2, and then x is equal to 4. So our three critical numbers are x equals negative 3 over 2, x equals 1, and x equals 4. Now we're going to come over and make a number line system to analyze what's going on. So I put two horizontal lines to place our values. For the one on top, I'm going to put x minus 1, and for the one on the bottom, I'm going to put quantity 2x plus 3 times quantity x minus 4. And then what we have here is we just look at the critical numbers. The first one we're going to introduce is negative 3 over 2, which goes right below the denominator number line. And then the next one we have is x equals 1, that goes here below the numerator line. And then finally in the denominator again we have x equals 4. And then on the top we put down the sign or value if 0 or undefined. Anyway, let's go ahead and look at, for the numerator, when x equals 1, the value of the numerator is 0. When x is less than 1, we have the value of the numerator is negative. So we put negative sign here above the negative 3 halves, and negative sign here. And at greater than 1, we have the value of the numerator is positive. Positive, positive, positive. And now we're going to go down to the denominator, and if we have a value of less than negative 3 over 2, we have a negative times a negative, which is positive. At x equals negative 3 over 2, the value of our denominator is 0. Between negative 3 over 2 and 4, we have a positive divided by negative, which is negative. So negative, negative, negative. And at x equals 4, the value of our denominator is 0. And for greater than 4, we have a positive times a positive. And so now we can make a summary summary here of the signs. And less than negative 3 over 2, we have a negative divided by positive, which is negative. At negative 3 over 2, we have negative divided by 0, which is undefined. Then between negative 3 over 2 and 1, we have negative divided by negative, which is positive. At 0, we have 0 divided by negative, which is 0. Between 1 and 4, we have positive divided by negative, which is positive. At 4, we have positive divided by 0, which is undefined. and greater than 4, we have positive divided by positive. So now we can answer the questions here. And so for A, we say f of x equals 0 where, and we just look down the summary line where x is equal to 1. B, f of x, because that's what we're being asked, undefined, f of x does not exist, and we see these undefined places here where x is equal to negative 3 over 2, and also x equals 4, because that's where we see undefined. C, f of x is greater than 0 on, meaning on the interval of, and we look for the positive signs here. We see 1 here between negative 3 over 2 to x equals 1, and also over here for greater than 4, so 4 comma infinity. And finally D, f of x is less than 0 on, well, the first negative we see here is for greater than negative infinity all the way up to x equals negative 3 over 2, and also between x equals 1 and x equals 4. Now what I did is earlier I went to the TI-84C calculator and put in the function, and graphing the function, this is what we see. We see the two negative intervals, one between negative infinity to negative 3 over 2 and between 1 and 4, and the positive intervals between negative 3 over 2 and 1 and from 4 to infinity. And where the zeros are vertical asymptotes where the function is undefined. So just for corroboration. Next, I'm going to go to the odd number problem 27. Here we have f of x equals x times quantity x plus 3. Well, to find the critical numbers, we can take x times square root of quantity x plus 3 and set that equal to 0. So we have x is equal to 0, and we also have this square root of quantity x plus 3 is equal to 0. And of course x equals 0 is a critical number, and then we have the square root of x plus 3 equals 0, so therefore x plus 3 is equal to 0, so x is equal to negative 3. So those are our two critical numbers. And also another constraint that's going to happen is we have this radical, so we also know that x plus 3 has to be greater than or equal to 0. So x has to be greater than or equal to negative 3. So that's also a constraint. So let's go ahead and make our number line here, which is going to be x times quantity x plus 3. So we put the number line here, our critical numbers on the number line, which are x equals negative 3 and x equals 0. So just evaluating what we have here, at negative 3 we have 0 times negative 3, which is 0. Between negative 3 and 0 we're going to have a negative times a positive. The square root of x plus 3 is positive wherever it exists, so we're going to have negative here. At x equals 0 we have 0. For greater than 0 we have a positive times a positive. And then less than negative 3 we have the constraint where we know that the function does not exist for less than -3, so it's undefined. And now we have everything we need. We don't have to have a summary encapsulation between two number lines. We just have everything on one number line. So we can answer the question right now. A, 0, f of x equals 0, where x is equal to -3 and x is equal to 0. B, f of x does not exist on, and it's going to be on an interval here at this point, from greater than -infinity up to x equals -3. C, f of x is positive, or I'll put f of x is greater than 0 on the interval of, we look for the positive, for greater than 0 to less than infinity. And finally D, f of x is less than 0 on an interval of -3 to 0. So that's going to be problem 27. Let's go to the next on our problem, which is 29. We have this f of x equals square root of quantity x plus 5, and then over the denominator, which is quantity 2x plus 1 times quantity x minus 1. So I'm going to set the numerator to equal to 0. What I'm going to do is just say x plus 5 has to be greater than or equal to 0. So x has to be greater than or equal to -5. And so x equals -5 is one of our critical numbers. And for the denominator, we're going to have this quantity 2x plus 1 times quantity x minus 1 is equal to 0. So we have 2x plus 1 is equal to 0, and x minus 1 is equal to 0. And then subtract 1, we get 2x is equal to -1, and x is equal to -1/2. So that's one of our critical numbers. And then x equals 1. So we have -5, -1/2, and 1 being our critical numbers. So I'm going to write the number lines out here. I'm going to put down here quantity 2x plus 1, x minus 1. And so that's going to be a number line for that here. And then above, I'm going to put square root of quantity x plus 5. So I have this number line up here. Okay, so let's go see where we are. The lowest critical number we have is -5, so I'm going to put this right here. That's representing the denominator. No, I'm not. It's representing the numerator. Okay, and then we have these other two critical numbers of -1/2 and 1 from the denominator. So looking at -5, at -5 we have the value of the numerator is 0. For less than -5, the function is, the numerator is not defined, so I'm going to put does not exist to the left of 0. And for greater than 0, everything is positive, or greater than -5. So positive, 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 positive. So I'm lining up the positive signs above all the intervals and other critical numbers. Now for the denominator, to the left of -1, we're going to have a negative times a negative, or positive. So that's positive there, that's positive there, that's positive. at negative 1/2 we have 0, and then between negative 1/2 and 1 we have negative, at 1 we have 0, and then greater than 1 we have positive divided by positive. And so for this, our summary, we have our first interval here is does not exist for greater than negative infinity up to negative 5. At negative 5 we have 0 divided by positive, which is 0. Between negative 5 and negative 1/2 we have positive divided by positive, which is positive. At negative 1/2 we have positive divided by negative 1/2, which is undefined. Between negative 1/2 and 1 we have positive divided by negative, which is negative. At 1 we have positive divided by 1, which is undefined. And then greater than 1 we have positive divided by positive, which is positive. So now we can go ahead and write down our answers. So A, we'll say f of x is equal to 0 where x is equal to negative 5. B, we'll say f of x does not exist, and the does not exist will be on, we have negative infinity up to x equals negative 5, and also at x equals negative 1/2. So I'm going to put a bracket here, negative 1/2. And then lastly, this value of x equals 1. Okay, C, we have f of x is greater than 0 or positive on the interval. We just look for the positive signs here. So we're going to go from negative 5 up to x equals negative 1/2, and union, we're going to have greater than 1. So it's going to be 1, comma, infinity. And the last one we have here, D, f of x is less than 0 on, we see just this interval here between negative 1/2 and 1. So negative 1/2, comma 1. So that's it. Okay, now we go to problem 31, and make sure this is in our field of view here. Okay, we have again our numerator. So we're going to find our critical numbers. I'm going to set the numerator equal to 0. I'm going to put this quantity 2x plus 5 times square root of quantity x minus 3. We're going to set that equal to 0. And so we're going to have 2x plus 5 is equal to 0. And we're going to have this square root of x minus 3 is equal to 0. So we're going to have 2x equals negative 5 and x equals negative 5/2. That's going to be one of our critical numbers. And then we're going to have for this other one x minus 3 equals 0. So x is equal to 3. So we have two critical numbers from our numerator. And we also have the condition that I'm going to put this up here at the top. We're going to have x minus 3 has to be greater than or equal to 0. So therefore x has to be greater than or equal to negative 3. So that's a constraint based on this radical. And finally, for the denominator, we're going to have x minus, I'm going to put quantity x minus 4 squared is equal to 0. So therefore x minus 4 is equal to 0. So x equals 4 is our other critical number. So we have these three critical numbers to account for. So let's just go ahead and write out our numerator and denominator. For our numerator, we're going to put this quantity 2x plus 5 times quantity square root of x minus 3. And so we have that number line here. And then for a denominator, we're going to have quantity x minus 4 squared. And so that's where that number line goes. And then we just place our critical numbers respectively where they belong. The first one we see is from the numerator. We have negative 5 over 2. And the next one we see here, also from the numerator, is 3. And then from the denominator we have x equals 4. And then at x equals negative 5 over 2, we have our value of our numerator is 0. Between, well, let's just go ahead and work this out here. What happens is we have x is greater than or equal to negative 3. So at negative 3, we have the value of the numerator being 0, but to the left of 3, the function does not exist. Right, so does not exist here, does not exist to the left of negative 5 over 2, and to the right of 3 we're going to have a positive times a positive, so we're going to have positive, positive, positive. And for our denominator, we're going to have at 4 we have the value 0, but positive everywhere else. If we square a negative number, we'll have positives. We have positive, 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 and positive. So our summary less than negative 5 halves we have does not exist. But we do not exist all the way up to x equals 3. So it does not exist all the way up to here. And at 3 we have 0 divided by positive, which is 0. We have between 3 and 4 we have positive divided by positive, which is positive. And then we have at 4 positive divided by 0, which is undefined, and greater than 4 we have positive divided by positive. So now we can summarize here. A, f of x is equal to 0 where x equals 3. We have f of x is undefined or does not exist on from greater than negative infinity up into x equals 3, and also here where x equals 4. And we're going to put a bracket here. Undefined. Actually, it would go like this: 4 up until 4, and then I think it, well, does not exist, so I'm going to have to put a bracket. Does not exist at that number is where I'm going to put it. Okay, C, we have f of x is greater than 0. We have these intervals here between 3 to 4 and union 4 comma infinity. And finally for D, we don't see any negative f of x. We'll say f of x is less than or equal to 0. We'll say nowhere. So that's what we have there. Let's just take a quick glance at 32. Yeah, similar type of problem. So I hope this number line analysis has been helpful to you. For you taking calculus next year, this is going to be very helpful. I hope you enjoyed this. As always, thanks for viewing.